Hello everyone, this is Dr. Martin Wucher and I have prepared a three-part series on practical corona tips for my fellow Namibians and whoever is interested, whoever's got the time and leisure and the interest of looking at this. So let's get stuck in. It's been split in three. The first part is basically a background thing. The second part is what you can do at home, which is probably the most important one. And then the last one will be a short series on what treatment options are available that you might or might not want to share with your doctor. Hopefully, you will find a doctor who will look at this and maybe even interested in incorporating it into his toolbox. So let's get going. There's a short warning. This is not medical treatment. This is not medical advice. It is basically to give you information and to set you on the road that you know what to do for yourself and your loved ones to hopefully prevent getting this virus. If you get it, have a mild disease and then come out of it with everything intact. Why we're talking about this, I don't think I need to tell you. This is a big hype. This is the big story. This is the story of the day. And as you can see on this slide, there are a huge amount of different ideas, theories. I don't know what is true, and I don't think any of us is in a position to really understand and know what the truth is behind all this. And this is probably the biggest problem we have, because on the one hand we have governments in our environment that are trying their best, but they are guided by their limited resources, by their limited experience with this sort of thing, and quite honestly every one of us is human, so we are all influenced by what we hear every day, you could say every minute. The ultimate question and the core of this whole story is actually one thing and one thing only. What do we need to do to come out of this alive? This sounds radical, and it's actually quite easy to come out of this alive. And as you will see, if you have the facts and if you've got a guideline of what you expect, let's say a roadmap, then life will return pretty much normal to you and you know exactly where you want to go. So let's go back and see what's been happening around us and actually where we are today. This was taken last year from the World Health Organization, and it's about chronic disease. And why I put that in here is because we are inundated with diseases that will kill us ultimately. In fact, many of us and the older ones have got more than one, and we don't often die a natural death anymore. We die of these things, these situations. And quite honestly, we have got so used to it that we don't even recognize it anymore. If you look at this graph, we probably have 1,600 cases dying of cancer per day in the US, and we've got 25,000 cases dying of cancer in the world every single day. If you look at something else that we know quite well, it's our annual flu. If you look at the Center of Disease Control, which is an American institution, you will see that they've worked out that between 12 and 60,000 deaths have happened annually in the last 10 years. Currently, we are at about 40,000 deaths from the flu in America. And this has been shown on the little peak here, on the little yellow tip. This is the annual flu, let's call it epidemic. You will also notice, although we've been vaccinating against this stuff, it just seems to stay the same. I don't know if it really goes backward. In fact, 2017-18 seemed to have been quite a bumper. These are the normal news clippets that we get inundated with, and this is nothing out of the ordinary anymore. In fact, many of us are sick and tired of this information. So much so that you battle to convince people to listen to something that is relevant to them. What's happened before? This is a short summary, and you can see here that we have been exposed to coronaviruses for many, many years, quite honestly, possibly 20 years plus. Started in 2003, 12, 15, and now it's the same type of virus, once again in a different format. If you look at this information here, a bioweapons expert, Francis Boyle, looked at all these components of the virus and he found that there are four different parameters found that are part of this virus. First of all, there's HIV, there's some influenza, and there's also some SARS or corona part. And those viral components have been found to be associated with Prevotella, which is a bug that gives you pneumonia. So at the end of the day, we've got a new mixture, a new component that has attacked people first in Wuhan and China, and then of course it spread wherever where we come. Up to now, or let's say on the 4th of March, we had a mortality of 3.4%. In other words, roughly 4 people out of every 100 that contracted that virus died. And if we look at these statistics here, and this is basically yesterday, it's much the same. The cases have gone quite a long way up, 140,000, and then the mortality is 5,500, maybe 6,000. So we're at a mortality of about 4%. If we look at the big picture here, and this was yesterday, and we take as death per day, then the coronavirus is somewhere around 100. And if you look at the other diseases that are listed in this graphic, it actually strikes us that we are really terrified of something that has got very little impact if you look at the total numbers. That doesn't mean it's terrifying and horrific if you are involved in a situation like that. But for us as a human species, especially in Namibia, if we play our cards right and if we stay calm, we will be absolutely fine. Let's go look at what the virus is. Many of you have heard about it. Let's just have a quick look at how these things are, how these little organelles, how these pathogens or microorganisms are composed. They like a golf ball. When you take the white of a golf ball, inside is curled up a whole lot of rubber band. So the virus has got an outer shell which is made up on the outside of oily stuff. It's pretty much like a double layer of oil, or oil bubble, and then underneath it there is some protein, and also sticking through the oil are these little mushroom-like structures, these spikes. They like Velcro upside down, and these little Velcro tips are made of proteins, specific proteins, and they can actually stick to your cells, and then the virus can go into your cell. But it has to attach to the cell first, and we'll get back to that because these little spikes are important for your immune system to recognize the virus. Inside the virus, there is genetic material called nucleic acid, and there are two types. There is a double strand, which is called deoxyribonucleic acid, and then there's RNA, which is a single strand. And the single strand is what we find in the viruses that we're talking about, in the HIVs, in the herpes virus, it's also in the coronaviruses. And because it's a single strand and these little bases stick up and they're exposed, any damage to these little things will influence the virus very much. So at the end of the day, an RNA virus has got a higher rate of mutation, a higher rate of change, because these bases are not protected, and any radiation, any oxidation, anything that can damage nucleic acids will influence RNA viruses much more. We've got another RNA virus that we all know. It's rabies. In Namibia, we know our dogs have to be inoculated or vaccinated against it. Sometimes wild animals like jackal have it, and they tend to bite people. and then people have to also be vaccinated and treated. How does a normal virus function? It's actually a little particle that is not alive. It's like a seed. It's got all the genetics, all the tools in to go and make a journey in which it ends up making more of itself. So you can imagine it's like a grass seed. It'll go into the ground, it'll grow, and ultimately that grass seed will make more grass seeds to propagate himself. A virus needs a living cell, either in a plant or in a human or in an animal somewhere. Um, Even in bacteria, they're called phages, but they are viruses that infect bacteria because bacteria are little living organisms and not like viruses. So if you see up here, you have viruses infecting a cell. They go into the cell, they open up their genetic material, which gets integrated in the host material in the genetics of the living cell. And then in a long process, more virus particles get made and they get released. And in the release, they leave behind a dead cell. It's like your teenage son walking into a garage, using up all the petrol, using up all the grinder blades, fixing up his bike. And when he's out and he's left with his bike, the garage is in chaos. Okay, viruses can lie dormant for many, many years. They can actually also integrate into our genetic material, and then they are called endogenous viruses. And something that is irritating to your body can trigger your virus, and then they can start growing. Viruses suppress the immune system. So when you've got a viral infection, you're very likely to get a bacterial infection afterwards. And that is why doctors may give you an antibiotic after you had a viral infection for your lung or respiratory system. Antibiotics, as we know it, do not work on viruses. They only work on bacteria. So remember, when the virus is done with your cell, the cell is dead. In COVID, the components, as we've discussed, are three different types of viruses. The question now is, has it just happened by chance, or was this designed by some evil entity? I don't think we will ever know the absolute truth, and it actually isn't that important. Quite honestly, for these talks here today, what is important is what we can do to come out healthy. It's not important even if it's a virus, it's not important if it's a radiation issue, because there are so many theories around, some of them even deny that there is a virus. And I'm not going to go into that, it also doesn't help us. We want to do something that makes us safe, and we can get out of this in a couple of weeks' time, all being healthy and carrying on with life. So let's have a look. It's an RNA virus. You can see the nucleic acids. It all has a lipid layer. It's a double fat layer that keeps this whole thing together. And that is really important, remember, because later on when we want to clean our hands and we wash our hands, we will explain why soap works so well, because soap will dissolve a double fat layer. And when the layer gets destroyed, all these little protein pins that stick up fall out, and then the whole virus can't work anymore. And then the last thing, these little protein pins that stick up are like Lego tips. They are like Velcro, and our immune system recognizes them, each one for every virus, and then they make antibodies. And antibodies are like little, you could say, little sticky traps. So when a virus comes along and you've got the right antibodies, they stick to these tips, and then the virus can't work anymore. The double lipid system is found universal in all living organisms. It's got these triglyceride molecules. It's got a head there and tails that go this way, and then from the other side they work the opposite way. These yellow bubbles are cholesterol, and these are the proteins that are sticking inside that that double lipid layer. So this is your own cell. It looks like this. In a virus, is just a simple version. And you can imagine when the virus comes along and he's also got an oily bubble, it's easy for him to fuse into this oily bubble. It's like two little oil bubbles on the soup that get joined together, or soap bubbles. They touch each other and whoop, they fuse to form a new one. So this is how the virus gets into your system. Here is what we call a liposome. A liposome is an oily bubble. Now, scientists and pharmacists have found that this is a great way. They put your medication or they put your vitamins inside an oily bubble, and it's called liposomal vitamin C or whatever. And when this fat bubble touches your mucous membrane, the oil dissolves with the oily part of the cell, and it imports the vitamins or the drugs in no time very efficiently into the cell. So this is called liposomal delivery of drugs or supplements. This is our friend, the COVID virus. Once again, it's got this specific double lipid layer, and this is really important for us because this is a key issue where you actually can attack the virus and can nail it, because you can imagine that oil, if it gets warm, it gets destroyed. If it gets exposed to alcohol for a while, or if it gets exposed to a mixture of alcohol and soap, which we will show you later, it'll dismantle this chap pretty quickly. This is what it looks like under the electron microscope. This is what we see, interesting, and this is also why it's called coronavirus, because it's got this halo, this little crown, which is corona is the Latin name for crown. Right, where do these chaps come from? They have been around all the time. They are normally living in animals. It's called the reservoir of the virus. The place where they stay is animals. And it's similar to flu, because flu often sticks around in birds in Asia, and that's why we call it Asian flu, because then it changes, it jumps onto people, and then we have flu epidemics every year. At the moment, COVID-19 is not in animals anymore. In fact, it's still in animals, but it's not important for us anymore. It's now in the human reservoir, and we are passing it from human to human now. Because unless you're eating all these funny animals, you're not really going to get it. And yes, it might have been the source originally, but also then this virus is a mixture of at least two different types. That's what the scientist tells us. But at the moment, it's the human-to-human issue that is important. Now, we've all had a cold or a tummy bug. Let's have a look how that works. Normally, the virus gets introduced into you via your mouth and nose, goes down your throat, it goes to your stomach, and it infects the intestines, the surface layers, and it replicates. It makes many billions of itself, and in the process it destroys the inside lining of your gut, and then you get a little jippos. You get a runny tummy, you get a stomach ache, and you might even get nauseous. And then a day or two or three later, when your immune system kicks in, and it's a huge war inside your body, you will have body pains all over. And that's what we know from when we get the flu. Then ultimately in the end, the virus goes back to be distributed to other people. It's a really clever system. So you will get a sore throat, you will cough and sneeze, and your lungs want to get rid of the liquids, and in that process, the virus gets passed on to other people. Once the virus is gone, or once your immune system is nearly done with the virus, the lungs and the tissues where the virus was are all raw and damaged. And then you can get secondary infections like the Prevotella virus or some specific cocci that go and infect the lungs. And that is why your doctor might give you an antibiotic to try and prevent these secondary bacterial infections. Here we have a sample of this influenza and the coronavirus. They go to the lungs, and then we've got the noroviruses and rotas. They go to your intestines and they make a stomach bug. Your lung is a huge area. If you look at the surface, it's like half a tennis court. So you can imagine if you inhale some spray from your neighbor that's been sneezing and coughing, it's got lots of space to do its thing and many, many places where it can attach. Once again, you see these little Velcro buttons that'll stick to your lung tissue, and then your lung will be infected. Now, this is quite an important slide. I want you to notice at the bottom here, we've got a picture of the lung tissue. Say that is your trachea, your windpipe. So you inhale air, and in the air are little droplets of mucus with virus and or dust particles or whatever, and they get trapped in the mucus. And then the mucus will work them up towards your mouth, towards your nose. You either blow your nose or you swallow them down and they get digested in your stomach system and passed out, or they end up in a tissue that you hopefully throw in the bin. But if this mucus layer is dry, or if you're a heavy smoker, then all these little cilia, these hairs that are supposed to move the mucus out, are paralyzed. They've actually been killed over the years. So now the virus can sit there for hours, and guess what? When you're old and weak, when your immune system is not okay, these little cilia don't function. You also might be dehydrated, so that layer isn't watery, it doesn't run, and everything is stuck and sits for a long time. Your chances of getting infected is very, very, very high if you're in that situation. Also, your immune system has to be intact. If you look at the picture at the top here, imagine these are antibodies. So now a virus comes here, and as I've said, the antibodies will basically velcro the virus together, and then it'll be moved out. So your immune system has to be absolutely 100%, and you need to be hydrated. This is the reason that we will tell you later, drink lots of water, get your immune system in top shape. Let's look at what happens inside the cell. The virus will come onto the surface of the cell. The two oily membranes will fuse. The genetic material will go to the middle of the cell. It'll be replicated, and then in these so-called ribosomes, which are these little blue guys here at the bottom, viral proteins are made and new viruses are built. It's like a car factory, and at the end we will have new viruses popping out. Many, many, many millions. And they infect the next cell. So here we have, this is the process. Viruses coming in, disassembling the genetic material, being used inside your own cell to make more viruses. And then eventually it's called budding. They get kicked out and they are set free to cause more trouble. This is just an indication how big they are. They are tiny little guys. You can see at the bottom here, 0.5 or 5 micron is half of 1,000th of a millimeter. So it's really tiny. The symptoms of the disease. Now look, there is so much in the internet. I actually don't have to tell you. You can look it up there. So if you want to know more about this virus infection, especially pertaining to Namibia, please go and check out the series number 2. It'll be in another video. All will be on YouTube, and you can share it with your friends eventually, and hopefully it'll give you a better idea of what to do. These are the symptoms, as I've said, but you don't need to check it here. You can see them on the internet. Thank you for your time. Have fun and stay healthy.